we end this lecture with a discussion on maintenance options and time-dependent reliability. Maintenance is broadly of two types. We have preventive maintenance and breakdown maintenance. Now, breakdown maintenance is really relevant for repairable systems. And as you remember, this term repairable is a technical term. It means that the item of interest can be taken offline completely and be replaced by an identical new version. So for structures, that is not really an option. Our structures are essentially of a non-repairable kind from that definition. So obviously we can do preventive maintenance on a structure. We can, again, to use the English word, we can repair it, but it's not a repairable system in the sense of reliability engineering. So for non-repairable systems, we cannot take the attitude of waiting for failure, so we have to act proactively. We have to act beforehand. We can maintain it and increase the strength of a damaged member. We can even increase its strength to as new condition, but we cannot take the system offline. One good output or outcome of preventive maintenance is that hidden failures can be detected. That is failure of redundant elements. So this discussion from this point forward is only about non-repairable systems and of a preventive kind. So let's say we know through a reliability analysis that the item's reliability will fall below the target at some instant of time TU, which is before the end of the service life, or the hazard function is expected to exceed the target for the first time at some instance TU. Now, obviously the TU in both cases do not have to be the same, and the word target does not mean that that's desirable. It's just that that is the acceptable limit. Now, we can have four possible corrective options. Make the item stronger so that no repair becomes necessary. Again, this repair is the English word repair. We're not talking about repair in the reliability engineering sense. We have already done that. We can restrict loads. We can replace the item by a new item at time TU. Again, we are going to come to that option in a few seconds. Or we repair the item well before this time instant TU. Now, let's comment on each of these four options. So, making the item so strong as to no repair will be necessary, no maintenance will be necessary, may sound good, but it may be unpractical. It may not be economical at all, although in some cases it may be necessary, but it's not always the first option. Restricting loads can certainly work, but it is impractical because if we restrict loads on a structure, then we basically limits its usefulness. So that's also one of the less desirable options. Replace the item by a new item. Obviously, it's a very defensive approach. It's what is done in safe life philosophy, but it's generally uneconomical. And for a non-repairable system such as a structure, it's the last resort because you're basically demolishing it and building it new. The fourth option is generally the best, and that is what is preventive maintenance. So we are going to discuss preventive maintenance, that is repair the item well before TU, at which time either the reliability is expected to become unacceptable or the hazard is expected to become unacceptable for the first time. So let's see if we can put this in the context of some mathematical formulation. Let's say we perform repair at time tr, and then that repair is going to alter the hazard function. Let's say before repair the hazard function had the form h0 as a function of time, and after repair the hazard function becomes h1 as a function of time. Now we can always integrate the hazard function between 0 and t and exponentiate its negative value to get the reliability function. So we can perform that integration. So before tr the reliability function is as before, and at tr if we perform the integration in two intervals 0 to tr and then tr to t, then the reliability can be written as the product of that value at the repair instant multiplied by the exponential of negative integral tr to t of h1, the new hazard function. Now we can call that second term, that exponential of the integral from tr to t, that term we can give it a new name. We can call it r prime and t minus tr. This is not the reliability function in general. Let's just give it a name, r prime. So we can, this actually tells us that r of t can be given as the product of r tr and then r prime of t minus tr. So then if we have perfect repair at time tr, then basically the hazard function recreates itself. It just resets itself with the time lag tr. So with perfect repair, h1 becomes equal to h0 as it was tr units of time before. So h1t is equal to h0 at t minus tr. Likewise, if we have perfect repair at tr, then r dash t minus tr, r prime t minus tr is equal to r of t minus tr. So with perfect repair at tr, we have r of t as the value that was there at the instant of repair multiplied by what r would be at t minus tr. So there is one interesting observation here, is that even if we do a perfect repair, the reliability does not become 1 at the time of repair, because reliability is a non-increasing function. So you can actually reset the clock on reliability, but that is the second term, r of t minus tr, but it's always going to be scaled down by r of tr, which is a number less than 1. So that's how r and h behave differently, and we'll now see the result of that through some examples.